This is a video clip based on kinematics of a 120mm mortar round. I'm Kevin Rosario.
And I'm Derek Tovis. Next is a clip of a mortar platoon actively engaged in firing a 120mm mortar round.
One command in it. One ready? One ready.
Be quicker than that. Don't worry about it.
Alright.
Fire machine's going, Bob. Rip the round.
Hang it!
Yeah. Push it out.
Hold it on. Alright, Phil.
There you go. One time I need a stool.
Stand up. Hang it!
Hang it!
Fire! Fire!
A 120mm mortar projectile round is shot from the edge of Two Lovers Point Cliff with a height of 115 meters above the ground level towards Paseo Park in Hagatna. The initial velocity of the mortar round coming out of the mortar tube is 318 meters per second. The angle of the mortar tube is positioned at 55 degrees facing south towards Paseo Park. We started by drawing a diagram of Two Lovers Point facing towards Paseo Loop. The list of known and unknown given variables were at 318 meters per second for your velocity. The angle of the mortar tube was at 55 degrees, and the height of the cliff is at 115 meters. On the x-axis, our x initial was at 0. Our x final is unknown. The velocity initial and the velocity final are the same at 182.4 meters per second. Therefore, acceleration is 0 because the velocity is constant. On the y-axis, the y initial is at 0, y final is at negative 115 meters. Velocity initial is at 260.5 meters per second. Velocity final is unknown, and the acceleration is negative 9.8. The time is also unknown.
Here we have our three kinematics equations that will help us complete our objectives. Here is our 6 objectives. A. Determine the time taken by the projectile to hit Paseo Park. B. Determine the distance that the mortar will travel from Two Lovers Point to Paseo Park. C. At the instant just before the projectile hits Paseo Park, find the horizontal and the vertical components of its velocity. D. What is the magnitude of the velocity? E. What is the angle made by the velocity vector with the horizontal? F. Find the maximum height above the cliff reached by the projectile. To determine time, we use number 2 kinematics equation and plugged in the known variables. Negative 115 equals 0 plus 260.5 times t plus 0.5 times negative 9.8 times t squared, which led me to use the quadratic equation to finish off our calculations, which we ended up with 54 seconds.
For letter B, determine the distance the mortar will travel from Two Lovers Point to Paseo Park. We used kinematics equation number 2 to solve the distance, which gave us 9,850 meters, or 6.12 miles.
Letter C. At the instant just before the projectile hits Paseo Park, our horizontal component is 182.4 meters per second. We use kinematics equation number 1 to help us solve our vertical component, which gave us negative 268.7 meters per second.
D. What is the magnitude of the velocity? Here we use Pythagorean theorem equation, which gave us a velocity of 325 meters per second or 727 miles per hour right before impact.
E. What is the angle made by the velocity vector with the horizontal? We use arctangent to find the angle, which gave us negative 56 degrees below the horizontal or 304 degrees.
F. Find the maximum height above the cliff top reached by the projectile. We use kinematics equation number 3, which gave us 3,462 meters above Two Lovers Point, or 11,358 feet high. This concludes our presentation. In summary, a motor shot from Two Lovers Point with a velocity at 318 meters per second, or 711 miles per hour, will reach Paseo Park with an impact area of 30 meters, or approximately 100 feet radius, which could take out the entire baseball field.
We'd like to thank you for watching our video clip and give you an insight into what our soldiers go through day to day. Thank you.